Okay, there we go. All right, so here's the plan for today. Today we will do 6.3 notes. Wednesday we'll do study guide, chapter 6 study guide. Thursday you will take your test over chapter 6. It'll be available from 12 that Thursday bright and early morning all the way to midnight Thursday night. So that's then. You'll also have access to pick up your final study guide. You can pick up your finals study guide starting on Thursday. I'll have those available at the school or online where you can print. All right. So that is that. And then you won't take your final exam until next Thursday, the 28th. And then once you take that final exam on the 28th, I think out this morning, we'll do one study guide day for the finals. So it's a 40-question final. It's over the whole year. And any question, and I'll work with you a little bit, Andrew, because I know you weren't here at the beginning. But we'll go through, I can go through that study guide, answer any questions you all may have pertaining to any of that. Does that make sense? Give me a head nod.
Mm-hmm. How much time will we have for the exam?
I'm probably going to give you about 3 hours for it. It'll be available all day. It shouldn't take you 3 hours because it's multiple choice. It is open note, open calculator. So you guys are going to be able to have your basically free run at that. Yes, Taylor.
Can I exempt your exam?
I don't care. Yeah, if you have an exemption, feel more than I am totally fine with that, with you exempting it. So I gave a hard time to some of my honor kids trying to exempt it, but just because they're bums. But other than that, no. If you want to exempt, I'm totally fine with it. I can't really say no, unfortunately. If I could, I would. Trust me, I would. How is that possible? All right.
Make a direct hit.
So let me switch over to this, and then we can get going here, guys. Hey, I just want to make sure that you all see this correctly. Is this the correct way to you? It's backwards to me, but is it correct to you?
Yes.
Okay, cool. All right. So jumping into 6.3 notes. Again, this is our last lecture, guys. So this should be, and it's a little bit of a long one, but it's your last concepts you have to understand. And what we're talking about today is logarithms. And if you have your calculator, go ahead and get your calculator out just somewhere near you, just so you have it. Do I need to zoom in a little bit more?
Yes.
No.
Okay, there we go. Jake, you ready for a haircut, man?
No, I don't even know what I'm gonna do with it. It's just really bad.
Yeah. No.
What up, Babs? Jake, let me give you a fade, bro.
Bro, all right, bet. Come over.
All right, I'm on my way.
All right.
Okay, so looking at something we want to do. First thing we want to do is let's go solve some equations. Solve equations. And let's go back to some simple equations like this. 2x equals 8. Okay. And what would we do there? We would simply do inverse operations, right? It's being multiplied right now, so the inverse of multiplication is division, so we divide both sides by 2. And we get x is equal to 4. All right? Pretty simple, common knowledge of equations right there. And then if I was to do another one like x plus 2 equals 4, here I would subtract by 2 on both sides in order to get x equals 2. I do the inverse operation. Okay? If I had something like this equation, x squared equals 4, What's the inverse operation of squaring something? What would be the inverse of that?
Square rooting.
Square rooting. I get x equals plus or minus 2. So the inverse of multiplication is division. The inverse of addition is subtraction. The inverse of squaring is the square root. But what if I gave you something like this? 2 to the x power is equal to 8.
Wasn't that the graph thing that we did?
Right. Oh, yeah. So it's part of chapter 6. Remember, if you had if you had 2 to the x, remember it's just that graph going up, right? That exponential graph. So we call this equation right here, we call this exponentiation. I better make sure I spell this correctly. There we go. Exponentiation. And here's the thing when we're looking at this. Does anybody know what this answer is? What is this answer? 2 raised to what power is 8?
2 cubed.
Yeah, 2 cubed. Yeah. So the answer is x equals 3. Okay. But, and that's solving it logically, just knowing that 2 times 2 times 2 is 8. But the inverse operation, the inverse of exponentiation is what we call a logarithm. The inverse of exponentiation is what we call a logarithm. Okay. Now, here's what that looks like. You basically change the format of this 2 raised to the x equals 8, and it comes out to be this. Log base 2 of 8 is equal to x. Log base 2 of 8 is equal to x. So it may look, I know this looks totally funky, and you're thinking, man, what in the world is a log? Okay, are we talking about something in the woods? No, we're talking about the inverse operation of exponentiation. So notice what we've done here is we've just made the 2 a base of a log. Remember, how do I find x? I do the inverse operation to find x, which is a logarithm. So say log base 2, your 8 comes over here, and then your x goes to the right side. Okay. Now, the cool thing about this is that this is a calculator type lesson. So if you have your calculator, this is where that log button down here to the left of 7 comes in. Okay. This is where your log button comes in. Now, you're going to see, we're going to see here in a little bit, that when you hit log, it just says log, okay? Doesn't really give you that option for that base, okay? So, but what you can do, okay, in order to get that base on there, and I'm not sure with older calculators, so one of you guys can tell me if this works for you or not, but if you hit math, and then if you scroll down here to the bottom, you'll see something that says log base. Do you all see that?
Yes.
Then just hit enter. And now you're set up for a log base. Okay, so now what we want to do is we just want to type in what we have here. Log base 2, so log base 2 of 8. And when we hit enter, we get 3. Kind of confirming our logical answer that 2 cubed is 8. Okay, so here x equals 3. And it equals 3 because 2 cubed equals 8. Okay, so guys, basically there's just one thing you need to know. You need to know what logarithmic form is and what exponential form is. They're just they're basically like inverse operations. Okay, they're inverse operations. Just like if you can go back, I'm sure y'all remember the first day of school, or not Andrew, but some of you guys, that when we did those squares, okay, and you had like 17 squared, and then over here in the next column you had 289. And some of you guys were sitting there confused as all get out on the first day of school thinking this dude is a weirdo. But you then found out that, oh, this is a shortcut. The square root of 289, the square root of 289 is 17, and 17 squared is 289. You learned that those are inverse operations. The same thing here with logarithms. You just got to know your forms. So we have exponential form. An exponential form looks like this. A raised to the B equals C. Logarithmic form looks like this. Log base A of C equals B. And really, guys, what that log is asking us is when you type in a log here, okay, just like we did right here. Oh, sorry about that. Just like we did here. Here's what this is, a logarithm is basically saying. This base raised to what power is 8? This base raised to what power is 8? And we found that to be 3. So whenever you're thinking logarithm, or what is a log, it's the inverse of exponentiation. When you're trying to find what exponent will work there, we're going to do the logarithm, which is the inverse of exponentiation. Now, you're used to seeing this, though. You're used to seeing x squared, right? The parabola. But now it's changed. It's not x squared. It's 2 raised to the x power. The inverse of this is the square root. The inverse of this is to do a logarithm. Okay? The inverse of this is a square root. The inverse of this is to do a log. And yes, Maria, it is recording, and I will upload it on YouTube. Okay? That's the basic concept of kind of what we're doing today. Is just you having the ability to, when you see a variable as the exponent, that you know, oh, in order to solve that, I need to do a logarithm. How do you do a logarithm? Right here on the calculator. Pretty simple. All right? So that is that. Let's jump down here to number 1. First thing, it says rewrite each equation in logarithmic form. Okay? Now, logarithmic form is written like this, okay? We just say log. The base right here, this base of 17 becomes the base of the log. 289 comes over here, and 2 goes on the right side. Okay. So someone spit to me what the next one would be. What would number 2 be? Not everybody talk at once.
Log base 13. And then 169 equals 2.
That's it. Again, on my calculator, if I come over here to my calculator and I turn it on, now the shortcut to doing to getting a log base is just hit math alpha math. Again, I'll show you that again. If you hit math alpha math, and the only reason that works is because if you go down to math and scroll down, log base is actually A. So I'm just hitting alpha and I'm hitting A. Okay. So if I say log 13 of 169, I get 2. And that's correct. Again, what is a logarithm? It's just saying this to what power equals that number. Now these are pretty simple. We know that 17 squared is 289. We know that 13 squared is 169. Okay. Now let's go the opposite way. Let's go from logarithm to exponential. So to go from a log base 18, 324 equals 2, that would be 18 squared equals 324. What would the next one be? Somebody?
$13 squared equals 169.
13 squared equals 169. Is that making sense to you guys? Any questions on going from logarithmic to exponential, exponential, logarithmic? All right, let's jump down here to number 5 then. So it says evaluate each expression. Log base 4 of 16. So what is that asking us to do? Can anybody tell me what that's asking us to do there? I mean, obviously we could use our calculator right here, but what else is, what is it basically asking us? Anybody know? It's saying this, 4 to the what power is equal to 16. And you got to figure out what power. 4 to the what power is 16. And what would that answer be there? Anybody?
4 squared.
2, right? Which is 4 squared. So when you see a log, it's just basically saying what power. What power is the base? The base raised to what exponent equals that number. Okay? Over here, 2 to the what power is equal to 32. So how many 2's do you have to multiply by itself to get to 32? Does anybody know that answer? How many 2's? Is it 5?
Yes.
Thanks, Taylor. All right, flip it to the back. Okay, looking at number 7, 8, 9, and 10. So here we go. 2 to the what power is 8? What would that be?
3.
3. So again, you're always asking yourself, this number right here raised to what power is equal to the number there? All right, jumping over here, number 8. 7 to the what power is equal to 343? And that would be 7 times 7 times 7. 7 times 7 is 49. 49 times 7 would be 343. So that'd be a 3 there. All right, then going to 9 and 10. Same thing here. Do what you're taught. I know it looks a little bit weird. I know it's fractions. Everybody starts freaking out. But do what you're taught. 7 raised to what power is equal to 1 over 343? Now, we just saw that 7 raised to the third power is 343. But what would make it 1 over 343?
-3.
Negative 3. Yeah, very good. It would be negative 3 right here. And some of you may be saying, well, why negative? If you remember with negative 3, what do you do with this negative? Can't keep it as a negative. Kick it out. And whatever you have left, put it under what? 1. And then 1 over 7 cubed is 343. So our answer here is negative 3. All right, how about this one? 2 raised to the what power is equal to 1 over 16? So 2 raised to the what power is 1 over 16?
-4.
Negative 4. Man, look at Taylor getting in on the action. Negative 4, very good. I forget that most of you people in here are from my first period. So that means that all of you guys are like literally dead people like walking. I forgot about that. How could I ever forget that you all never answered anything? It's a little bit different in your class, Tara.
Yes, it is.
They're a little bit more talkative. You guys would check on me if I died. If I died at my desk in third period, they would just sit there, and when the bell rang, they'd just get up and walk out. And no one would ever say a word.
Well, ours is 8th period, so I mean.
Yeah, no, it's not first, it's third period. They've already been there 2 periods during the day. So come on now. That's
No,
not
but ours is last period, so.
well,
we'd
and
be
you all
ready
have
to leave.
have Karen, so
Yeah, that is true.
What's our IPOC?
hold on, I want to show you my face when I said Karen. Karen.
Wait, do your best impression ever.
There is no impressions of Karen. Karen is our only she is a unique individual. What were you going to ask me, Taylor?
Are you teaching pre-calc next year?
That would be correct.
You are?
I chose
that-
pre-calc.
I gotta change my schedule.
I switched from trig to pre-calc. I'm so happy.
To my knowledge, if everything works out smooth, the way everything is working out right now, which I'm sure some of you guys have heard kind of the changes happening. But in terms of the math department, but there's going to be a little bit of change this year. But to my knowledge,
What changes are happening?
Have you heard anything? You hadn't heard anything, Jake, about teachers leaving?
No.
Who's
No.
leaving?
Oh, okay, yeah. Then I can't discuss it if you hadn't heard. I assume that you all had heard because news travels pretty fast. So, but yeah, if you all hadn't heard it yet, hear it from someone else, not me. But I can tell you what I'm teaching, and I'm teaching just as long as everything goes smooth, Algebra 2, Pre-Cal, and AP Cal. So I saw Jake. Jake? What did you sign up for? Stats?
Yeah.
I'm shaking my head right now, and it's not up and down; it's side to side.
I can change it if you want me to.
No, I don't want to. No, I don't want to force you to change it. But Jake, you're pretty sharp, man. Everybody in this room should be taking it. Pre-Cal, but I understand, Jamie, don't even make that face. But I understand that it is your senior year, so it is kind of hard to say, like, man, I want to commit to pre-calculus. And next to that, Mr. IPOC's pre-calculus, so you know it's going to be the grind, you know. So a lot of people want to take a smooth road their senior year. And I'm not saying stats is a smooth road. I'm not saying that at all. I heard this year got a little bit tougher in there. So I don't want you to think I'm saying that at all. But I would push yourself as far as you can go. That's what I would encourage you to do. All right. Jumping back to this, thank you for interrupting our class, Taylor, with
You're
such
so
a
welcome.
such a
Anytime.
weird question. But going back over here to our notes. So there's a couple things I need you to kind of understand, and I left some space here to kind of write those things. All right. There is a common logarithm, and the common logarithm is what we call the base. It's called the base 10 logarithm. Is called the base 10 logarithm is called the common logarithm. And is written as log x with the base 10 implied. Okay, so now you may be, and let me just show you. So like it looks like this. Log of x is equal to the same thing as log of 10 base x. Okay? So let me kind of explain that a little bit more with the calculator. All right? So, oh, sorry. I'll give you a second to get that down. All right. So when I'm looking at my calculator, here's what I want to show you. If I do that alpha math, and get the log base, okay, and I say 10, if I put a 10 as my base and 100 over here as the next number, what is this answer right here? What's log base 10 of 100?
Isn't it 2?
Yeah, just 2. Yeah. Because 10 to the what powers is 100. So we know that's 2, okay? But now watch this. If I just come down here to the left of 7 and hit log, I don't get the base. I just get the word that says log. And if I do log of 100, I get 2. Okay? So what we're trying to show you is this. The common logarithm is a base of 10. All right? So this log right here, it's just written as log of x. This has a base of 10. Make sense? So anytime, log of 1,000 is 3. 10 times 10 times 10 is 1,000. All right? Well, that's the same way with log base. If I say log base 10 of 1,000, that is 3 as well. So just trying to show you that anytime you get something that's a log, okay, log, most common logs, the common logarithm, it has a base of 10. It's written like this, but it can also be written like log of x. And it kind of goes back to like the thing, like, if I have an x right here, if I just have some random x right here, I don't have to put a 1 there. I know it means 1x. Just like with the square root, right? I don't have to put a 2 there because this is just universally known as a square root. It's universally known that there's a 2 there. Does that make sense? So with log, you don't have to write log base 10. You can just write log x because it's universally known that that right there is the same thing as log base 10 of x. Okay? So then the other logarithm is called the base e. The base e Now, who remembers what E is? Do y'all remember what E is? It's very similar to what?
Pi.
Pi, 2.71828, and then 4, 5, and obviously we go on forever. That E, and again, that's the maximum amount something that's compounded continuously can go to. The base E logarithm is called the natural. It's called the natural logarithm and is written as ln. It's kind of backwards here. It's like ln of x. Sorry about that. And guys, ln of x is equal to ln of e raised to the x, or e to the x power. So you're basically going to have two logarithms you're going to deal with. The natural logarithm, which is this right here, and the common logarithm, which is this right here. Okay. So now just to kind of show you with the calculator, okay? So watch this. If I do math, the log base, math alpha, math. Now here, the natural log, this has an E for the base. So that E, where's that E at? It's the division sign, right? E raised to the, I don't know, let's just say that, let's say 10, okay? That equals 2.3. And that should make sense because 2.7 raised to the 2.3025 should be equal to 10, all right? But now here's what you need to know. This LN button down here, does everybody see that LN button below log? The LN button below log, okay? If you hit that and you say LN of 10, what is that going to give us? Should be the same thing, right? And that's what I need you just need to know those two things today. If you have a log with a base of 10, then you just say log of 10. If you have a log with a base of e, you can just say ln, or natural log of 10. I just don't want you to leave today saying, what in the world is a log? I've heard horror stories of people understanding what logs are, okay? We're not talking about something in the woods. We're talking about the inverse of exponentiation, okay? It helps us find exponents that are missing when we have some particular base. All right, so continuing on right here, guys, number 11. Now it says this for us to do. Solve the equation, round your answer to the nearest 10,000ths. That's going to be fun. So let's look at that. Now we could do this a couple different ways, but I'm going to show you one way, and that one way should be pretty easy for everybody here. All right. So looking at this, it says 10 raised to the n power is equal to 68.3. What do you all, if my goal, guys, is to find n. I want to see what n is. Okay. Now here's the thing. Here's what I do know. I know that n right here is going to be 68.3. I know it's going to be less than what? 2? Because 10 squared is 100. So I know it's going to be less than 2, so that can kind of help you make sure you're getting the right answer. So what do y'all think we should do here in order to solve for n? What happening? Can someone tell me what's happening here?
Do the ln formula?
Not quite the ln. What is this called? This is called when you have a variable as an exponent. What is that called on the front side?
Exponentiation.
Yeah, that's it. And what's the inverse of exponentiation?
Logarithm.
A log. Okay. So let's just change this to log form. Well, what would this be as log form? Log base 10 of 68.3 is equal to n. What'd you get, Taylor? Is it a number less than 2?
Yeah, it's 1.8.
Okay. So let's do that. Math, alpha math, log base 10 of 68.3. 1.8344. Now, what is 10 thousandths? What place value is that after the decimal?
That's the first one.
Oh?
Like it goes 1 and then it's the first one, isn't it?
No, 10 thousandths.
Oh.
No, not the tenths. Yeah, tenths would be correct.
Yeah,
But where's 10 thousandths? You skip what do you skip? You skip ones, right? Then you go tens, hundredths, thousandths, 10 thousandths. So it's the 4th decimal place. So this answer would be 1.8344. The two here doesn't round the next 4, so it's 1.8344. N is equal to 1.8344. And that's the way it'll be on your homework as well. So you'll see the answer there, rounding that to the nearest 10. All right, let's go to the next one, number 12. So this is what we call exponentiation, when you have an exponent that's a variable. And we just need to do the inverse operation of exponentiation, which is what? What's the inverse operation of exponentiation, Jamie Dozier?
Log form?
Yep, log. Okay. So we're just going to change it to log form. So talk to me, Taylor. What would the log form be of this?
Log 10 times 83.
Or just log 10 of 83 is equal to, okay. Does that make sense? Now tell me this, do I have to do on my calculator, so guys, I'm not expecting you to get this number in your head, but in my calculator, do I have to go, do I have to say math, alpha math, and get the base? I don't have to. What can I say here? Tara, I see you shaking your head. I
Just
can just say
log.
what?
Just log.
Just log. Why can I do just log? Because that's the common log, and the common log has a base of what? 10. So log of 83 will give me my answer. And that's K is equal to 1.919. And what does that 7 do to the 0? It rounds it up 1. So 1.9191. And again, just to prove all you people that don't think I'm really telling you the truth, that is the same thing as this right here, log base 10 of 83. If it's not, I'm a liar. I guess I naturally would be a liar anyway, though, you know, based on what the scripture says. All right. Is this making sense to you guys? Give me a head nod at least. Jake's totally disappeared with a messy bed. I can't believe he doesn't make his bed. That's the problem with this generation. If you guys don't make your bed, it's going to be bad. There's a book written that's called Make Your Bed. And it says it's how you start a good day is by making your bed. Okay? All right, let's jump to number 13. Number 13. 13 is 6 times 10 raised to the r power is equal to 45.9. So looking at that, guys, what should we do first? Anybody? Should we just change it to log form right now? No. First thing we got to do is remember, the only time we go to long form is when we have it in that exponential form. Right now it's not an exponential form because they have this 6. So I need to divide both sides by 6 first. So when I do that, it cancels on this side, leaving me 10 to the r power is equal to 45.9 divided by 6 is 7.65.
This is the only mom.
Jake over here
Okay,
talking to
I
his
just
mom.
happened to see that we got that email and I didn't see it.
Come on, Jake. You got to be better than that. All right. Jake's mom done checking in on the email. She's like, you got that email right? All right. So then from here, once I have it in this exponential form, then I convert it to what form, Andrew?
What's it called?
The tree thing, man. The tree.
Yeah.
The log. So I can just say log of 7.65 is equal to r. Did I put my base 10 there? I did not. Do I have to?
No.
No, because that's a common log with a base of 10. So what is log of 7.65? 0.8837. Because it's 366, so we got to round it up. Okay. Jake, did your mom get your outfit picked out for you today, buddy?
No, I was asking her about the printer.
Oh, okay. Oh, I'm sure. I figured she was putting your outfit out for the day. Make your bed too, Jake. But come on, man. All right. Jumping over here to number 14. Come on, yeah. There's girls in the Zoom. You got to make your bed. Don't look so sloppy. My goodness. All right. So divide by -2 on both sides. Got to do that. That's 10 raised to the n power is equal to +8. And then we just say log of 8 is equal to n. And of course, if you feel more comfortable, I know you guys are kind of creatures of habit. If you want to put that base 10 in there, that's fine. So log of 8 is equal to, n is equal to 0.9031. It's 9038, so that rounds that 0 up to a 1. Okay. So then from there, let's go to the back side. All right, looking at 15. Now, all right, so oh boy. There we go. Okay. So now looking at 15 here. So now looking at 15, what I want to do here is divide both sides by 8. And I got 10 to the 2p is equal to 97 divided by 8 is 12.125. All right. So then from there, I'm now ready for logarithm form. Okay. So I say log of 12.125, and of course I could say log base 10 is equal to 2p. Now, what's different about this one than opposed to the other ones we've done?
It has a variable.
Well, no, they've all had variables, but it has something with the variable, right? So it has a 2p. So once we get this number, what are we going to have to do with it in order to isolate p? Say it louder, Taylor.
Divide.
Yeah, divide by 2. Okay? So let's get that. That right there will be log of 12.125 is equal to, well, sorry, is equal to that right there, 1.803. Now, here's the thing. I'm going to give you permission, or actually, let me do this, log of 12.125. I'm going to give you permission, guys, that you don't have to write this down right here, okay? Don't feel like you have to say 1.0836 going on and then divide all that by 2. I would just get this number right here, and then from your calculator, then say divided by 2. So it's this number right here divided by that 2. So we're basically doing that right there. And then we're saying P is equal to whatever the answer is divided by 2. 0.5418. Is that making sense? Okay. I assume that makes a little bit of sense to you. All right, do number 16 on your own. See what you guys do here? I'm gonna give you a second. Work 16 on your own. Use your calculator, and then I'll jump in here in just a second. What answer did you all get? Just say it.
Negative 0.1204.
Can anybody confirm with a head nod? All right, very good. So I assume you divided by 8 first. 97 divided by 8 is 12.125. Cancels. 10 to the negative 9p is equal to that. Then say log base 10 of 12.125 is equal to negative 9p. And then so we say log of 12.125 is equal to 1.08 divided by -9. P is then equal to, you say -0.1204?
Yes.
All right. Oh, sorry. Yeah, that's correct. All right. Any questions on any of that, guys? Okay, cool. Jump down here to the next one. It says solve each equation, round your answers to the nearest 10,000ths. Now look at this. It says e to the r equals 6. So again, now e, don't get twisted. E is not a variable. What is e? 2.7, 1828, 1828, 4590, 45. Okay, that's what e is. It's an irrational number. So when you have this right here, we have a couple different options, right? We just need to change it to a logarithmic form. So what would this right here be in logarithmic form? And this applies to any base. You just say log. Anytime you have a variable as an exponent, you say log base e, that's your base, that's of 6, is equal to r. But now what did we learn? What is log with a base of e? What is that? A log with a base of e. That's called the natural log, which can be written like this. ln of 6 is equal to r. Does that make sense? So then in your calculator, now we're just going to say natural log of 6. And that's our answer, 1.7918, because the 5 rounds to the 7. So r is equal to 1.718. Now, if you ever want to check your answer, just plug it back in. Just say e raised to the that there, and you should get 6. 5.9 repeating. Okay, so that's 6. So it's an easy way to check your answer. Just plug it back in. All right, what would the next one be? How would I write the next one? Can someone tell me how I'd write the next one?
ln of 78.
Yep, is equal to x. X is equal to 4.3567. Jacob said I won't be on here till I get back. All right. 19. 9e raised to the r equals 17. So first step there. How about a BAPS? Talk to me. First step, what I need to do there. Was that a I don't know or?
Yeah.
All right, so our main goal is to get it to where it looks like this right here. E to the r equals a number. That's called exponential form. So what I need to do with that 9 to get it off the e raised to the r?
Do you have to like square root it or no, you divide it?
Divide it. Where have you been, Jake? Are you literally sleeping in the Zoom class?
Well, I mean, I'm just confused a little bit. I
On
mean,
what?
just like I don't understand how to log it.
Okay. And that's
Like I know you put it, yeah.
1.8 repeating. So it's all form, Jake. Everything's just changing form and then using your calculator from there. So like up here, so anytime you have something where the exponent is a variable, that's called exponentiation. And in order to figure out what that variable is, you have to change it from this exponential form to logarithmic form, which basically just takes this base, puts it there, takes whatever's on the right side, put it there. And that's what you type into your calculator. Okay? But when you have a base of e, that's the same thing as a natural logarithm, what we discussed on the other side when you were talking to your mom about emails. All right? So, but feel free to rewatch it. If you rewatch it awake this time, I can't even keep you awake in class. And now you're falling asleep in Zoom. But, you know, I guess you're kind of chilling in your bed. So that makes it a little bit more reasonable. So e raised to the r is equal to this. So now right here, look, when I have that variable, that means I want to find out what r is. E raised to what power is 1.8 repeating? So that's where I come with the log at. Log of e is equal, or of 1.8 repeating is equal to r. So again, e drops to the base. This side comes over here. R goes on that side. Now I can rewrite this as ln because the log base e is just ln of 1.8 repeating is equal to r. When I type that into the calculator, the ln of 1.8 repeating, I get r is equal to 0.636.
Wait, how do you do the repeating?
Yeah.
You just put a bunch of 8s. You put a bunch of 8s in there. Or what I did was this. I just hit LN and then I hit up and I just click on that. But if I didn't have that, I'd just say LN of 1.888 and I just spam 8 for a little bit as long as I could to get my answer. Does that make sense? And then notice it's 6359. That 8 rounds that 9 up to a 0, which rounds that up to a 6. So it's actually just 0.636. All right, jumping over here, number 20. All right, first step, Jamie, what am I going to do first here? I need to isolate that e to the p power.
Gonna divide by 6.
-6, right?
Mm-hmm.
Cool beans. E raised to the p power is equal to 74.5 divided by 6 is equal to, it's actually equal to 12.416, and the 6 is repeating. So that's pretty nasty. Then from there, we're just going to say ln of 12.416 is equal to p. Okay. Now again, if this was me doing this, guys, I would just say ln, and I would say 12.4166666, and I would just kind of spam 6 for a little bit and hit enter. 2.519. 2.519. Is that, are you all getting that as well?
Yes.
Yes, sir.
Okay.
Do we not put 0?
You can, but you don't have to.
Okay.
All right, last 2 problems, guys. Then we'll close it up. It hadn't been that bad.
Mm-mm.
So, 21, e raised to the -1.4, -1.4 n minus 1 equals 15. What do I need to do with that -1 first?
Add.
Add 1 to both sides. That's e to the -1.4 n is equal to 16. Again, I want to get this right here isolated. So once I get e by itself, or 10 by itself, whatever the log would be, I got this variable here. This is exponentiation. What's the inverse operation of exponentiation? Logarithmic, or logarithm. So log base E is of 16 is equal to negative 1.4n. That's the form you need to know today. You got to know how to do that, okay? You know how to do that, you'll be fine. Now, universal, the two most used logarithms is log base E and log base 10. Log base E is what we call the natural logarithm, so we say ln of 16. But if you use this calculation, you're still going to get it right. Natural log of 16 is equal to negative 1.4n. The natural log of 16, 2.7. This is like, and again, this is where, remember up there I told you, that's 2.7 something. But don't feel like you got to write that out. Just from there, you know that you got to divide that number by 1.4. And n is equal to, so I'm just going to say this number right here divided by negative 1.4. And I get that, and that's negative 1.9804. All right, you guys work 20, 22 on your own. 22. Okay, you guys good?
Yes, sir.
All right, so you added 1 to both sides, right? Got 23. All right, so, sorry, 25, right?
Yeah.
Okay, and then you said ln of 25 is equal to n plus 6. ln of 25. And you subtracted 6 from that number and got n equals negative 2.7811.
Oh, we subtract.
Negative, right? Is that correct?
Yes.
Why do we subtract again?
Okay, so do you know we got that number, ln of 25? You cool with that?
Yeah.
Just right here, then to find n, you would just have to subtract 6 from both sides.
Okay.
From that number. I didn't write this number down because it's a long decimal. Does that make sense?
Yeah.
And I just I subtract 6 and it cancels there, and then whatever that number is minus 6 is negative 2.781.
Okay.
Does that make sense, Taylor?
Yeah.
Any other questions of me on 22, 21, any of those? Guys, from there you got your homework. And then I won't see you guys again until Wednesday. We'll do the study guide, Thursday test. Thursday you'll be able to pick up your final study guide for those of you that are taking it. And then your actual final will be the following Thursday. So you'll have a week with that. And then we'll do on Wednesday a study guide review. Is that what I sent in the email? Can someone confirm that?
I think so.
Okay, cool. I think I said Wednesday at 11 o'clock. Okay? All right, if you guys don't have any other questions, you guys can have a good day. And I will see you guys on Wednesday, okay? Let me know if you have any questions, all right?
Okay.
All right, sounds good. Thank you.